Welcome to this P4 walkthrough. Right, we're starting with this first question, which is a partial fractions. So nice, easy start. Now you want to set your question up with, the right kind of form. So you want to make sure you are putting, a over the 1 minus x and b over 2 plus 3x. And you should always just double check, make sure this is not an improper one. So the highest power here is just that x term, isn't it? Whereas on the bottom is an x squared, so we don't have to worry about that. Next step is obviously to get over the same thing and then just look at the top. So I will skip a couple of steps here and jump straight to this, because this is obviously the top line. This would be where this is as a single fraction, like here. Okay, and then we've got, so start with x equals 1, and that will give us 5 plus 10, and that equals a, and it's 2 plus 3. So 5a equals 15, a equals 3. There's my first step. My next value I want to substitute in is going to make this bracket 0. So it's minus 2/3, isn't it? So if you think, if you can't remember how it is, you just put the bracket itself equals to 0 and then rearrange it. Yeah, so it's nothing too difficult. If you can't spot it, that's what you can just do. So I'm going to substitute in minus 2/3. So that is 5 plus, 5 plus, is it 5 is, and 2/3 plus 10 equals, and this one's going to be 0, and it's b 1 minus 2/3 there. So 20 over 3 equals 5 over 3b. So b is 4. Okay, and then it's always best to kind of put that back into the questions. We could pop it up here, so we would have 3 over 1 minus x plus 4 over 2 plus 3x. Now, next step is to find this, expand it up to x squared using the binomial series expansion. So, they could have asked that question right from the start and not put that bit in. You would have had to have put it into partial fractions. So just be aware of that. Okay, so I'm going to write this out now in terms of f of x equals 3 to the 1 minus x to the minus 1 plus 4 brackets 2 plus 3x to the minus 1. So I'll focus on the first term, 3 and the brackets here. So I'm going to do it up on the top of my screen. So 3 and 1 minus x to the minus 1. So keep the 3 outside, and then we have 1 plus minus 1 times minus x plus minus 1 minus 2 times minus x squared all over 2 factorial. And then that's as far as we need to go, just to the x squared term. So that gives me 3 brackets 1 plus x. And you think here you got, that's 2 divided by 2 is just 1, and then minus x squared is plus x squared. And I always like to leave this plus something, dot dot dot, because it does actually continue. And obviously in this case it's going to be 3 plus 3x plus 3x squared plus, and so on. Now we'll focus on the 4. Now this we need to rewrite a little bit different because we want the 1 here. So that would be, take the 4 out, 2, I'm going to divide by 2, so I'm going to take 2 outside. So taking 2 to the minus 1 outside, and that would be 1 plus 3 over 2x to the minus 1. Now this is obviously 2 divided by 2, isn't it, on the bottom? So that's like 4. If you want to write, this could be like 4 over 2, which is just then 2. So I've got 2 here on the outside, and then I'm expanding this. So same again, 1 plus, and it's minus 1 times 3 over 2x plus minus 1 minus 2 3 over 2x squared, and this is then over 2 plus, and then just carries on to squeeze that on the end there. So 2 brackets. Now what we've got, so we've got 1, and we've got minus 1 times that, so it's going to be minus 3 over 2x. And then we've got minus 1 times minus 2, so that's 2 divided by 2, so it's just 1. So that's going to say, and that's going to be 9 over 4x squared. So it's plus 9 over 4x squared. And then multiplying by 2, we get 2 minus 3x plus 9 over 2x squared. Now we've got these 2. What we can do is replace it back in here now. So we've got this plus this basically. And then it's just a matter of simplifying it. So we've got 5. And then in terms of the x's, we actually got 3x take away 3x. So that would go. And then we've got 3 plus 9 over 2, or 4.5. So that is plus 15 over 2x squared plus dot dot dot. And that is the rest of B part 1. Yeah, so that's B part 1. Now what we need to do is look at B part 2. Now I'm going to switch my pen up a little bit to green, just to do this in another place on here, hopefully to make it easier to see where I'm going. Now we have to find the range of values that's valid for each expansion. So I've got 2 different expansions, this one and this one. Now this one's just going to bring me back the old this case, isn't it? But when I look at this one, it's not quite yet. We're looking at here. So that's the one that's really going to change what my thing is. So got 3 over 2x is less than 1. So that would mean that 3x is less than 2x is less than 2/3. Okay, so if you think this one is between 1 and minus 1, like so from 1, minus 1 all the way up to 1, if you think of a number line, and this one is between 2/3. So it's here on the number line, 2/3. And it's there. So the one that works for both of them is this 2/3. Yeah, because that 2/3 is valid for both of the inequalities, or both of the expansions, I should say. So B part 2 is just going to be x bracket modular sign and 2/3. Okay, so just rub that out. That don't need that now. Hopefully that makes sense. And let's move on to the next one. So here we have a set of parametric equations, and we need to show that all points x and y lie in a straight line. So the easiest way to do that is to put these together and get them in the form of y equals mx plus c. Okay, now that isn't quite as easy as it stands, so we can see that a y equals 6 over 2t plus 1, and our x is also quite awkward. So if I look at the x equals t minus 1 over 2t plus 1, what I've really got to do is make one of these t equals. Normally I just make the x t equals and substitute it straight into the y, then I've got y equals. This one looks easier to make it t equals, but I'll stick with doing it with the x. We'll see how it pans out. So this is 2t x plus x equals t minus 1. And then we need to get the the t's on their own. So I think I'll take them to the right. So t minus 2t x, and then there's x plus 1 on this side. I've just done it that way so that I get a bit more, I get positive values. Take t out, 1 minus 2x. That's obviously still x plus 1, and then divide by 1 minus 2x, x plus 1 over 1 minus 2x equals t. So there we have t equals. Now let's substitute that in. So y equals 6 over 2 times, and then this is x plus 1 over 1 minus 2x plus 1. And now I just need to kind of sort this out on the bottom of this fraction. So let's go ahead and expand, and we get 2x plus 2 over 1 minus 2x plus, and then I want to make this an equivalent fraction, so I'll be able to combine it with this bottom fraction here, this one. So this is going to be 1 minus 2x over 1 minus 2x, because that would still be 1. Now I can go ahead and combine these two. So we get 6 still on the top, and we get 2x plus 2 plus 1 minus 2x all over 1 minus 2x. Here we can see that the 2x and the minus 2x will give me 0. So now I can go ahead, and I'm just going to bring this over here. So we can go y equals 6 over, and we've got 3 over 1 minus 2x. Okay, this top line now is just 3 over that. And of course, when you divide in by a fraction, it is the same as multiplying by its inverse. So we end up with 6 times 1 minus 2x over 3. 3 will cancel with that twice. So that leaves me with 2 minus 4x. So y equals 2, let's see, 1 times 2 and 2 times the minus 2 there is 4. So that's what we've got, which is linear, therefore straight line. Okay, and that is part A done. You could of course have made this one the subject, and it would have been a similar thing when you substituted in. It's just a bit of manipulation there. Now part B says, hence or otherwise find the x-coordinate of the point of intersection of this line and the line with equation y equals x plus 12. So that's what we're going to do. Hence or otherwise usually means that you can use the previous answer that you've got, and it will generally be easier that way, but it's not the only way. So, you know, even if you didn't quite get this out, you could use effectively these two to find the value of the x-coordinate here. So you could substitute this in and this in find value for t, and then once you know that, substitute the value of t just into the x one there. So it is possible, but obviously it's easier just to equate these. So 2 minus 4x equals x plus 12. 5x equals minus 10, isn't it? 2 minus 12, yeah. So x equals negative 2. Nice and easy. Let's look at the next question. Okay, so we've got this curve here and it is rotated 360 degrees, or 2 pi. So this should be just a nice integration. So for the volume, we've got pi times, and it's between a and b, y squared dx. So that's what we're looking at. So pi times, it's really this squared, so it's just 3x over 3x squared plus 5. And it's between 5 and root 5. Yeah? Just think this y squared is that 3x over 3x squared plus 5. Yeah? And therefore now I just need to integrate this. Now, if you have a little look at this one, you'll notice that the bottom, if I differentiated this bottom, it would give me something like this top. So what that means is that this is probably going to be one of those ones that you can do, because it's like the top's differential at the bottom, so it should be an ln answer. So what I'm going to do is I'm going to do this in another colour. So I'm going to just have like let y equal ln 3x squared plus 5. Okay, it'll actually be like that. Now, if I differentiate this, so dy by dx, I get 1 over 3x squared plus 5 multiplied by this inside differentiated. So that'll become 6x. So this would give me 6x over 3x squared plus 5. Now that's obviously double the size we want, because we actually want 3x on the top. So what we want to do is basically take this answer and times it by half. So that means I need to do the same to the start, so it would be a half. So this differentiated, or this, sorry, now integrated, because if I integrate this just this green, I would get this green. If I integrate this green with the red, I'll get this green with the red. So I get pi is still that, a half ln 3x squared plus 5, and then that is between 5 and root 5. Okay, and I can take the half outside if I want to, so, you know, for example, I can leave that half outside for now. So we get pi over 2, and then we've got ln, and it's 3 times 5 squared plus 5 minus ln 3 times root 5 squared plus 5. So leave my pi over 2 on the outside. So I've got ln 80 minus ln 20. So this equals pi over 2. Now ln 80 minus ln 20 is ln 80 over 20. Okay, and that is obviously going to be ln 4. And then we can, well, not stop there really. So, well, if I think pi by 2, this is ln 2 squared, I can bring the 2 down so that I end up with now ln log 2. Oh, what am I doing here? Apologies. Start again. Get pi ln 2. And that there is my final answer. I think had I not taken the half out and I kept it in, I would have had to put it up there and then sorted these out, and then it would have still ended up with 2 then in the end. But yeah, that's where I was at. That was almost done. Just be careful there that you can then simplify down a little bit further. Okay, and now this is in the form a plus b. Because a was irrational, hence the pi, and b a prime number, hence the 2. Obviously, if we left it like that, 4 is not a prime number. Okay, and that's the hint, just to make sure. So they're assuming that some of you will get down to this point and might stop there, but seeing that pi there, that b is a prime number, will make you go a little bit further. And that's that question done. Sorry about my phone going off there in the background. Right, let's get on to the next question. This is telling us quite a lot here. So we've got to show that using the sub, this becomes this. So let's start off with that. So I'm going to pop that. Well, I'm not going to bother actually. I'm going to say, this is always a good thing to do. I'm going to call this I. I equals that. So now I can go ahead and say, right, well, I is also, now we need to work these things out. So 2x plus 1 is what we want. So you can see here, this one, we can take 4 out. So if you think of this, this could be 4 times 2x plus 1, which could then split up into root 4 times root 2x plus 1. So 2x plus 1, which equals 2u. Yeah? So that's where we started, so we got to 2u. So we get, first place, 2u there. Now we need to deal with this. So e to the 2x plus 1. Oh, so it's just e to the power u. So this is times e to the power u. So far there we've changed 2 of them. Now we also need to change the values. So you can see that u equals root 2x plus 1, doesn't it? So when x is 4, u equals, so we got 4, 2 4s are 8, plus 1 is 9, square root of 9 is 3. And when x equals, what's the next one, 12, sorry, so x equals 12, u equals, so 2 12s are 24, plus 1 is 25, square root of 25 is 5. So that is that limit there. So we have now got our limits between 5 and 3. And then finally then we've got the dx to deal with, haven't we? And that's going to come from this. Yeah. So if we look at u equals 2x plus 1 to the power a half, then what we can do is we can differentiate. So du by dx equals 1/2 2x plus 1 to the minus a half. Yeah, and then times that by the inside differentiated, which is 2. So that means it is just, so these will cancel, leaving me with 2x plus 1 to the minus half. So this is 1 over root 2x plus 1, which is 1 over u. Okay, so that is du by dx. So dx is going to equal u du. Yeah, so times up by that, times up by that. So now we can go ahead and substitute that bit in. So it's also now times by u du. So this now is between 5 and 3, 2u squared e to the power u du. And now you can see that it matches that, where a and b is our 3 and 5 and k is 2. Now next step is now just to integrate this. Because I've changed my limits, I don't need to do any changing back, just integrate this and substitute in and solve. So let me just make some room. Now this is going to be an integration by parts. Now obviously normally we use u and v. It seems a bit weird using u and v in this case though, but it is the same thing. My u squared is going to be my u, and my v would be e to the power u. Okay, I'm also in this case I might take the 2 outside just to make it a bit easier, but it doesn't really matter. Maybe I'll leave it in to be less confusing. So we're going to integrate by parts. So this would be sorry, as I was thinking of it, it would be, let me put it in red. Obviously we wouldn't use these actual letters, but u and this one would be the dv by dx. Yeah? So we'd have 2u squared, and then e to the u would be my dv by dx. So if I differentiate the 2u squared, I get 4u, and if I integrate e to the power u, I get e to the power u. So that's not going to change there. So u times v would be 2u squared e to the u minus, and this is of course between still 5 and 3, as is this. Now minus, and then we've got to do v du by dx, so that would be 4u e to the u du. Okay, and then this one is also going to be by parts, so we're doing by parts twice. Yeah, so think about it now. We're going to have 4u is going to be my u, isn't it? And then e to the u is my dv by dx. So that'll be 4, and that's still that one, u to the u. So we're going to go with, so 2u squared e to the power u between 5 and 3, that is unchanged, minus, and I'm going to put this in a big bracket here. So this one now will be u times v, so that is 4u e to the u, minus, this is now between 5 and 3 still, and it is v du by dx, so 4eu du. Oh, right pain that, yeah? Obviously when you think about it, this is still 5 and 3 there. So just kind of get rid of all my brackets, just, well, not all of them, just simplify this a little bit. So we got this one between 5 and 3 minus, we got this between 5 and 3 plus, because it's a minus here times the minus, and then this one's going to be integrated to, well, it's just 4eu stays the same, doesn't it? Between 5 and 3. So effectively, you know, what I can do here is I could just now 2u squared minus 4u e to the u plus 4e to the u, and that's all between 5 and 3, because that's what I'm doing, whether I do it individually or all in one go. Next step is to pop this effectively into my calculator. What I would normally do is obviously I'd write a little bit out here, but I'm going to make it a little bit easier for myself. I'll stick on 5 and I'll write the answer down now. So all I've done here is substitute 5 into here. keep the e to the power 5 in there, and then substitute the 3 in. Okay, so keep the e to the power 3 there. Then what I can see is I've got 50 minus 20 is 30 plus 4, so I've got 34 e to the 5, power 5, minus, and I've got 18, so that's a plus there, isn't it? I've got 18 minus 12 is 6, plus 4 is 10, so we're taking away 10e to the power 3. And that can be simplified no further. Okay, and that's all there really is to it. Apologies, a little bit confusing here, but uv dy by dx, you know, that's the differentials on the bottom. So, you know, we start with the u and the dv by dx, but a little bit confusing, I suppose, but hopefully you followed it okay. Not possibly my best walkthrough question there, but anyway, hopefully you got it. And don't forget, if you do like this video so far and you are finding it useful, hit that like button and hit the subscribe if you haven't done so already. But let's get on to the next question. So here we're going to differentiate implicitly. So if we differentiate in dy by dx, so let's have a look. So we're going to have 2y dy by dx equals 4x plus 15 plus 10 dy by dx. So that is 2y dy by dx minus 10 dy by dx equals 4x plus 15. So dy by dx is 2y minus 10. Just factorising that out there. And then we need to divide by that bracket. So we get 4x plus 15 over 2y minus 10. Now, part B. So these asymptotes, they have like a gradient of infinity, so to speak. So what we know is that with our dy by dx, to get these two asymptotes, 2y minus 10 must be equal to 0. So 2y equals 10, y equals 5. Now, what I need to do is substitute that now into this equation. Okay? And that will hopefully produce the x values that I need. So we get 25 equals 2x squared plus 15x plus 50. So this is 2x squared plus 15x plus 25. And then let's see if we can put this into brackets. We'd have a 2x and an x. And it's going to multiply to give me, oh yeah, it's going to be 5 and 5, isn't it? 5 and 5. That's going to give me 10 plus 15. Yeah, so both positive. And that works. So therefore x equals minus 5 over 2 or x equals minus 5. So we've got p equals the minus 5 because it's further to the left, and q equals minus 5 over 2. And those are the two x values. That's all you need to find. Okay, we've got a vector question here, and it's all relative to the origin. So if you think, right, here's my origin, I've got vector, I've got point A here, and then I've got point B there, and I want to find the line L which passes through A and B, and I want to find that vector A to B. So this means it's going to be what is it? It's A to O plus O to B. Or a better way would be that it is a minus OA plus OB, or OB minus OA. So that is what we're looking for. So that is the position vector of B, so 8i plus 3j minus 7k, minus the position vector of A, so 2i minus 3j plus 5k. And that will be, so this is going to be not the line, this is going to be A, B. So we've got 8 minus 2 is 6i. 3j minus 3j is 6j. And minus 7k minus 5k is minus 12k. And that is our vector AB. So that is a part 1. Part 2 is actually the line. So it's got to be from one of the points. So we got 2 minus 3, 5, for example. Doesn't matter if you pick point A and point B. So that's the starting point. So it's got to be this one or this one. Doesn't matter. Then this is my directional vector. It's going in this direction. Okay, so this one, if I just go back to it, you can see 6 is a factor. So I could take 6 out and have I plus j minus 2k, like that. So plus, and then we want, say, lambda, and then 1, 1, minus 2. Okay, because that's just 6 times it. So this is just the direction, doesn't matter about the number. Obviously, if you still kept 6, 6, and minus 12 here, that would be perfectly correct. Yeah, the examiner would follow through. You'd have a different value for this in the later in the question. But that's about it. So either that one or this one, and this, or like this. It's just multiples of this, and that'll be fine. But it's easier to take the factor out, highest common factor there, to make this smaller, to make it easier to do. Okay. Now for part B, we've got P is on our line, our equation, our original line here, and C is just another point which is given to me here. So what I want to do is I want to find CP first of all. Okay, so that's what my start is going to be. So I'm going to find that CP. So I know what C is. It is 3, 5, 2. And just like when I was finding AB here, actually, let me rub that out. Let me start again. So just like when I was finding AB, I did it B minus A. So for finding C to P, I'm going to do P minus C. So let's start off with P. So P is 2 plus lambda minus 3 plus lambda 5 minus 2 lambda minus, and then C would be 3, 5, and 2. So that's what we got first of all. So that is going to be minus 1 plus lambda minus 8 plus lambda and 3 minus 2 lambda. There we have our C to P. Now, we also know that it was perpendicular, doesn't it? So we know A dot B is equal to 0, because cos of 90 is 0. Now, final step. So we've got the 1 minus lambda minus 8 plus lambda, sorry, that's plus, isn't it? And 3 minus 2 lambda. And this is going to be times the directional vector of our AB. And that equals here 0. If you want to find out a bit more from this, check out my video. It's actually the last vectors one on scalar products, 7.11. Check that video out. There's a little bit more explanation there. Okay, so let's multiply these out. So we got 1 times minus 1 plus lambda plus 1 times minus 8 plus lambda minus 2 times 3 minus 2 lambda. So that is minus 1 plus lambda minus 8 plus lambda minus 6 plus 4 lambda. So we've got there 6 lambda, and we've got minus 1 and minus 8 is minus 9 and minus 6 is minus 15. Take to the other side is 15. So that means, let me just make a bit of space. No, actually I'll just fit it over here. So we got 6 lambda equals 15. Lambda is 15 over 6. We can divide by 3, so it's 5 over 2. So lambda there is 5 over 2. So all that's left now is to find that position vector OP, or the point P, isn't it? So 2 minus 3, 5, plus 5 over 2, 1, 1, 2. So we got plus 5 over 2, we got minus 3 plus 5 over 2, and we've got 5, oh sorry, that's a minus 2 down there, isn't it? Minus 5. So our position vector is 9 over 2 minus a half 0. Or we can call it 9 over 2i minus 1 half j. That was a bit of a slog. It's not quite as fresh in my mind, the old vectors there. Hopefully you managed to follow it okay, but just hit me up in the comments down below, and as I said, check out the scalar products video as well. Okay, let's look at the next question. Okay, first part is just to find dv by dr. It's nice and easy, just multiply by 3, so we got 4 pi r squared. Now it says here, so we found this simplest form. At time t, the volume of the balloon is increasing according to this differential equation, so dv by dt. Given that v equals 0 and t equals 0, solve this differential equation to show that. Okay, so part B1, start with dv by dt, 2t plus 3 squared, and what we've got to do here is integrate it, so we get it plus c, and then we will just solve then. Oh, right, let's see. I think if I stick it like this, then it makes more sense. So v equals 900, and I'll put the 2t plus 3 to the minus 2 there. Okay, and this is going to end up with a plus c. So we get our 900 times, so it's going to be minus 2 add 1 would be minus 1 divided by minus 1, so it's just going to change that to minus 2t plus 3 is to the minus 1, and then we need to divide by the inside differentiated plus c. So that will go with that, leaving me with 450. So I get 450 over, it's a minus, and it's 2t plus 3 plus c. Now it tells me that v equals 0 and t equals 0. So when v equals 0, t equals 0, so we have 0 equals 450 over 3 plus c, and that's a minus, isn't it? So 450 over 3 is minus 150 plus c, so c equals 150. So that means that v equals, I'll run out of space here, 150 minus 450 over 2t plus 3. Obviously that doesn't look like this, so we need to make it one fraction. Couldn't think of the word there. So if you think it would be, oh, I'm going to need to make some more room here. That's better. So it is 150 brackets 2t plus 3 over 2t plus 3 minus 450 over 2t plus 3. So we've got that's not 150, is it? So 300t plus, now 3 times 150 is 450, minus 450, all over 2t plus 3, 300t over 2t plus 3. And, oh, that is what we needed. Perfect. So, part 2, find the upper limit of the balloon. Okay, so I'm going to show you a little trick for this upper limit. Now, put it down here in red. So this is what we've got. 2t plus 3, because we've got fractions here. Now, imagine dividing each term by t. So that would go, and that would be over t. Yeah, and it works because we've got this. So now we're looking at 300 over 2 plus 3 over t. Now, as t tends to infinity, 3 over t would tend towards 0. So that means that the volume then would be 300 over 2, which is 150. So my upper limit here for part B is 150. And the units are centimeters cubed. Okay, it's very useful for when you've got brackets there. Yeah, nice to it. So for this one now, we're going to find the radius of the balloon when t equals 3. Obviously, this is the formula with radius in it. We need to know the volume, so we need to substitute t equals 3 into this one to get the volume. So it's the volume in this one then to get the radius. So V equals 300 times 3 over 2 times 3 plus 3. So you've got 900 over 2 3s are 6 plus 3 is 9. So the volume is 100. And then we've got 100 equals 4/3 pi r cubed. So that's 300, that's 150, 75. So 75 equals pi r cubed. R cubed equals 75 over pi. R equals, and it's the 3 significant figures. So it's 2.87941 and so on, which is 2.88 to 3 significant figures. And of course that is in centimeters. Now the next bit says find the rate of increase of the radius of the balloon at t equals 3, given your answer to 2 significant figures. So for this one, we're going to need to be able to find the r by dt, because that's the rate of increase of the radius. Okay, I'll just make a little bit more room. So if we want the r by dt, then, and we've got a dv by dr here, you see, so we can have a dr by dv, and then we need a dv by dt. Yeah, that way the dv's kind of cancel, leave me dr by dt. So dr by dv will be this one, but upside down. So like 1 over 4 pi r squared multiplied by, and then dv by dt is given to us here. So that is 900 over 2t plus 3 squared. Now it also says that t equals 3, which is what we did here. So this means t equals 3 and then r equals 2.88, because that's from part C when t equals 3. So those are the values we want to substitute in. So 1 over 4 pi times 2.88. I'll use the full value though, stored in my calculator, times 900 over 2t plus 3 squared, and t is of course 3, isn't it? So it'll be 6 plus 3 squared, so 9. If I rub that out again, so that'll be 9 squared there. And that is 0.1066 and so on. So I just missed out the square there initially. Two significant figures, so 0.11 centimeters per second. Yeah, so per second, that's 2 SF. Of course, you can also write this as centimeters per second, like that, because it's a rate. Okay, not too bad a question. Okay, hopefully you found that relatively straightforward as well. Okay, and then let's move on to the next one. So we need to first find L here. It's the normal at P. So what we want to do is find the gradient at P and the point of P, and then we can find the equation of this line. So the point first, so P, so this is, the x coordinate is sine squared pi by 4, and the y one is 2 tan pi by 4. And then plugging this into our calculator, we get the P is 1/2, comma, and tan 45 is 1, so that's 2 there. So that's my coordinates for P. Next, I need the gradient. So I want dy by dx. So first thing I want to do is dx by dt. So that is differentiating sine squared t. So sine squared t, so it's going to become, so if you think of, sorry, if I just start again, let me just start again here. So here's my x, it's sine squared t, but I'm just going to take the squared on the outside. So this becomes 2 sine t times, and then sine differentiates to cos t. So here we have 2 sine t cos t. And then with the tan t, this is going to differentiate to sec squared t. Of course, that's in your formula booklet there. So here's how to kind of bits, and we know that dy by dx, which is what we want, is going to be, sorry, I just need to make a correction there. That should be by dt. So this is dy by dt times dt by dx. That's what we need. Now, this is obviously, we want this value when we're at p. Yeah, so this. So what we want to do is, we want to put these values, so it's like the pi by 4. Okay, so point t, yeah, pi by 4 into here and into here. So we'll just get numerical values. So I'll do that in green there. So 2 sine pi by 4 cos pi by 4. And that is just 1. And that also means that when we flip it, dt by dx, which is what we really want, is also 1, isn't it? You know, so 1 over 1 is just 1. Now we want to do the y, and I've just noticed something. This was 2 tan t, wasn't it? So this will be 2 sec squared t. Apologies for that. But let's put in our values. So 2 sec squared pi by 4. So sec is obviously 1 over cos. So we're looking at, you know, you're looking at the same as 2 over cos pi by 4 squared. So cos pi by 4 then squared is just a half. 2 divided by half then is 4. So those are our two values, which means that we got 4 times 1, which is 4. So gradient is 4, but for the tangent, isn't it? Now L is actually the normal, so it says it. So let me highlight it so you can see. So we've got it's the normal. So we actually need to use a gradient of, let's do it. So gradient of 1/4, and then it's negative. And then we've got the coordinates 1/2, 2. So using a trusty formula of y minus y1 equals mx minus x1 gives me y minus 2 equals minus 1/4 x minus 1/2. Now I'm going to start off with multiplying up by 4. I always do that. So I do it in one go. So 4y minus 8 equals minus x plus 1/2. Now I need to multiply by the 2. So we get 8y minus 16 equals minus 2x plus 1. And then the x is positive, as you can see there, and the y is, so taking everything to the left, or not everything. So we take the x's to the left, so we get 8y plus 2x. And then we add 16, and that equals 17. And that was what was required. You can see it quite clearly here. Okay. Now, before we get on to part B, let me just make a little bit of room. That's better. Now, when we're looking at part B, it says we need to find this shaded region. S is bounded by C, L, and the x-axis. So, what I want to do is I want to split this up. So the easiest way to do this is to split it up straight down here. So creating a right angled triangle there. And before we can go any further with that, we need to find this coordinate here, or this value along the x-axis. So along the x-axis is when obviously y is equal to 0. So the first thing I'm going to do is substitute y equals 0 in. So that gives me 2x equals 17. So x is going to be equal to 8.5, or 17 over 2. Now that I know that, I can work out this area. So I'm going to call this area 1 and area 2. Or actually, let me go with area A and area B. So area B is nice and easy. it's a half times the base. So the base there is, well, if I just redraw it on the side here, okay, it starts at a half and it goes to 8.5. Don't know why I wrote half, let's put it in decimals. So it starts at 0.5, goes to 8, so it has a base of 8, and the height there is from 0 all the way up to 2. And we get that just from the coordinates, yeah? So P's coordinate, that's where we're starting. So starting at a half along the X, and then 2 on the Y. So there we have, so that's just going to be 8 units squared. So we got area B straight away. Now we need to get area A. So area A is going to be integrated, isn't it? So it's between 0 and a half. And what I'm integrating is basically y, aren't I? So currently we think y by dx. And then we need to do a little bit of manipulation. So y would be 2 tan t, but dx is obviously the problem. So previously we had this multiplying up by the dt, and we would get this. So now I can say that this is times by 2 sine t cos t dt. Okay, so now I've got everything in terms of t. And then the only thing left to do is to work out my values of t for my two limits. Now I know the limit here, that is when t equals pi by 4. Yeah? And then my lower limit is 0. Because if you think about using this when x is 0, then t has to be 0 here. Okay, so that's what I've got now as my new equation. I'm just going to do a little bit of kind of simplifying it, so to speak. So let's sort this out. So tan is sine over cos. So we've got pi by 4 and 0. 2 and 2 is 4, so I'll take that outside. Sine t over cos t times sine t cos t dt. The cos will cancel, so it's a sine squared there. So now I'm left with between pi by 4 and 0 sine squared t dt. Now remember, we do generally prefer to change this into like a double angle formula. So if you can just see me in the top right here, cos 2t will be equal to 1 minus 2 sine squared t. Yeah, so if I swap it around, so 2 sine squared t is equal to 1 minus cos 2t. So that's what I want. So if you remember now, we actually had 4 outside. So on this one, I'm actually going to leave just 2 outside and keep 2 inside. So my 4 is now split up into 2 and 2, because then this will just straight swap for this. So now I am integrating between pi and 4 and 0. I've got 2 on the outside, and I've got 1 minus cos 2t dt on the inside. And then this will go something like this. So integrating 1 becomes t, and integrating cos, so if you think cos differentiates to minus sign, so it integrates the positive sign. So that's sine 2t, and then normally if you differentiate it, you would multiply by 2. So we're integrating, so we're dividing by 2. So pop a half in front of it. and then put that to be pi by 4 and 0. And now we just need to sort that out. If you wanted to multiply through by the 2, you could. So I could say, right, I'll get rid of the 2 here, and get rid of this half, and end up with 2t minus that. Okay, so that is another way then. I could just multiply by that 2 beforehand rather than afterwards. So here we'll have pi by 2 minus sine of pi by 2 minus 0 minus sine of 0. So we've got pi by 2 minus 1, and obviously the rest is 0 here. So we've got a total area. Let me put this in red so you can see and it stands out. So total area is pi by 2 minus 1 plus the 8. So it'll be pi by 2 plus 7. Okay, hopefully you followed that okay. Obviously I'm just trying to squeeze it in at the end, but it's just this area A plus area B. So pi by 2 minus 1 plus 8, pi by 2 plus 7. And there we have it, exact area. Right, let's get on to the final question. So we've got a proof by contradiction, and it's quite nice that it has started, so you haven't got to do any of the annoying assumption and stuff. So we've got it started, we need to kind of complete it. So to complete this now, we also say, right, we need to let p equal 3k plus 2, where k is an element of the natural numbers there. Because this is obviously not a multiple of 3 is what we're trying to do. So 3k plus 1 is not a multiple of 3, 3k plus 2 is not a multiple of 3. And then if we had 3k plus 3, that would be a multiple of 3, wouldn't it? So this now will cover all of the remaining non-multiples of 3. So consider p cubed, and we have 3k plus 2 cubed equals. So now we have to go ahead and expand this. So that's 27k cubed. And just think of using binomial expansion. You know, for the second term here, it's going to be, 3c1, and then it's going to be times by 3k squared times by 2. Yeah? So this is 3 times 9k squared times 2. So 54k squared. And when I think of the next term, it's going to be 3c2. And it's going to be multiplied by 3k times 2 squared. Yeah? So it's 3 times 3 times 4. 3 4s are 12, 36. So 36k. And then when we get to the last one, it's 2 cubed, which is 8. Okay? So you don't have to go through the whole process of multiplying out 2 of the brackets like a quadratic, and then multiply by that third bracket. So just using that binomial expansion there, we just sort out that 36k a bit, but just using that binomial expansion to make your life a little bit easier, a little bit quicker. Now we can go ahead and take 3 out just like they did in the question here. So we take the 3 out, so that gives me 9k cubed plus 18k squared plus 12k. Now this is a problem with the 8, so we'd want to take out 9, so it'll be 3 3s minus 1. So what we're actually doing here is we're splitting the 8 up into a 9 minus 1. Okay, so if you wanted to, you could put an extra line in here with the 9 minus 1 just to show it a little bit clearer, but you should be okay with just what I've written there. and then we want to put which is not a multiple of 3. Then we need to finish it with one final statement, just talking about our original statement in our assumption. Okay, now I'm going to be a bit lazy here, and I'm just going to copy and paste the conclusion from the mark scheme, because I didn't really want to write out a lot of words when it was just something similar. So anything like that that's similar to that would work fine here. Okay, so that's part A done. Part B is hence prove by contradiction that the cube root of 3 is an irrational number. So assumption. Sorry, I know I'm not very good at talking while I'm trying to spell. So now we got there exists integers P and Q such that the cube root of 3 equals P over Q, where P and Q have no common factors. So that's our assumption. So we have then this equals P over Q, and let's cube it. So we get 3 equals P cubed over Q cubed. So 3Q cubed equals P cubed. And that's obviously quite important there, because we've been dealing with cubes in the first part of the statement. So like from here, we can make some now statements. We can use that first part of the question. Sorry, I was trying to do therefore. So therefore, P cubed is a multiple of 3. So 3k cubed equals 3q cubed. Does that make sense? So we're basically saying, well, what we're boiling down to is now we've got these as cubes. That's a multiple of 3 and that's a multiple of 3. It's kind of obvious, isn't it? So p cubed is a multiple of 3, so we can write it as 3 times any value cubed. So that would mean that it could be 27k cubed equals 3q cubed. So that means that q cubed is equal to 9k cubed, which means q cubed is also a multiple of 3. And that's where our contradiction is. Now it says, so it's P and Q have no common factors. This is a contradiction. Hence, this cubed is an irrational number. So something along those lines. I might not have got it quite perfect there, but it's all kind of the same kind of stuff for these types of questions. So check back in, one of my previous videos if you want to know more with the proofs. I did quite a few of them. Okay, but it's fairly straightforward. You're just, proving your contradiction, and that's really all there is to it. So let me know in the comments down below if there's anything that you had a problem with. I will try and get to all of them, but I do also know that this time of the year I'm super busy with my own classes as well. Okay, but I do try and get to everyone I can, or certainly the most important ones. I don't always answer questions that have already been answered before, so please think about looking back in the previous comments as well if you're looking for an answer. And if you did enjoy or got some benefit from anything in this video, even if it's very small, please consider giving me a big thumbs up, a like there, and don't forget to subscribe if you find any of these videos useful and want more.